What's up, Corgi lovers? It's Miss Sorensen with video 24, probability of not something and the probability of at least one. These are pretty explicit formulas, but also pretty explicit questions because they literally have the phrasing, what's the probability of not rolling a 5, or what's the probability of picking out at least one green marker. So the problems are moderately reasonable because you know that it's this type of problem. All right. What's the probability of rolling a 6 on a die? Well, what is that probability? We know that that answer is 1/6, right? Yeah, that's right, because there's only 1 out of 6. But what if I told you that we can use this formula right here? Maybe pause this video and get that formula down. Okay, now that you have that formula down, let's solve this very easy problem with a different formula. What's the probability of rolling a 6? That's actually equal to 1 minus the probability of not rolling a 6. Okay. Well, what's that going to be equal to? That's going to be equal to 1 minus the probability of, well, what's not rolling a 6? That would be clearly a 1, 2, 3, 4, or 5. All right, well, what's the probability of rolling a 1, 2, 3, 4, or 5? Well, that is equal to 5 out of 6, right? These are 5 numbers out of the total 6 numbers. So this is going to be equal to 1 minus 5/6. Well, what's 1 equal to? That's equal to 6 over 6 minus 5 over 6. We're just combining these fractions here. 6 minus 5 is obviously 1. Keep your denominator 1/6. So notice how we get the same exact answer. And obviously you wouldn't solve this problem with this method. I'm just kind of showing you that it's true, that the probability of something is equal 1 minus the probability of everything else, or probability of not something. All right, let's try this one here. What's the probability of rolling 2 dice and getting values less than 12? Well, certainly what I could do is I could add up all these values, right? And you get, I don't know, 35 out of 36, right? That's the easy way. So we know the answer is going to be 35 out of 36. But let's use this formula. And again, this is not the easiest way for these two problems, but it's understanding why this formula works. All right, well, this would actually be equal to the probability of getting a value less than 12 is going to be equal to 1 minus the probability of not less than 12. Well, what's not less than 12? That would be 12 or greater, or in this case, really just 12, because that's our max. Well, what's the probability of getting 12 here? Well, that's 1 out of 36 options. Let's rewrite this 1 as 36 over 36. Subtract. And we get 35 over 36, which is exactly what we wanted to get. Again, we wouldn't do it this way, but it certainly really makes sense why the formula works. All right. Now, let's do a problem where I think the formula actually does help. All right, so here we've got 3 regular 6-sided dice are tossed at the same time. What's the probability of getting a sum less than or equal to 16? Okay, now that's a ton of things to count. And so we usually choose this formula when it's a lot easier to count the not something, the not. All right, so the probability of getting a sum that is less than or equal to 16 is equal to 1 minus the probability. Okay, now think of what is not less than or equal to 16. Well, that would be things that are greater than 16. Okay, so think about, you've got 3 dice that are 6-sided. What's the max you can get? Well, if you roll a 6, 6, 6, you can get an 18. So what are the cases that are the opposite of this? Well, the opposite of that is greater than 16. And that in this case is going to be both 17 and 18 because the max we can roll is an 18. So these two things are the opposite or are not these things, right? What's less than or equal to 16? Well, not 17 and 18. Those are bigger than 16. All right. So now we actually just have to find the probability of getting a 17 or an 18. And this is gonna be a little bit of work. Well, what are ways that we could get 17? Well, that would be, let's say, a 5, 6, 6, a 6, 5, 6, and a 6, 6, 5. You can add all those up, right? 6 plus 6 plus 5 is 17. That adds to 17. That adds to 17. And notice how I just moved that 5 around from the first position to the middle to the last. That just kind of helps me kind of keep track of these things. All right. All right. So that's all the 17s that we can get. How would we get 18 when we roll 3 dice? Well, that would be a 6, a 6, and a 6. So those are our 4 ways that we can get a 17 or an 18. But the question is, how many possible rolls are they? Because I'm asking for a probability. I want 1 minus 4 out of, what are the possible number of rolls for a 666 roll? Well, this is a counting principle. You're going to roll the dice 3 times, or you can think about it at the same time if you want. The first roll, you have an option of 6 different ways to get 6 different things. You can also, for your second roll, get 6 different things, and the third roll, 6 different things. And 6 times 6 times 6 is 216. So we've got a denominator of 216. So this is going to be 216 over 216 minus 4 over 216. I just made that 1 into 216 over 216. Keep our common denominator of 216. And then, of course, 216 minus 4 is 212. Reduce that fraction using that video that I showed you early on, and we get 53 out of 54. Now, this method was certainly much easier than counting the 212 ways that you can get less than or equal to 16 when rolling 3 die. Okay, let's try another one. You flip a coin 3 times, find the probability that at least one of your tosses is tails. All right. Well, this is interesting because now I'm not saying what's the probability of not something or using that formula. I'm now seeing this word, at least one of your tosses is a tails. Okay, so this at least one formula, I kind of want to show you that that is the same exact thing as this formula here. I've just written it slightly differently. All right, so the probability of something is equal to 1 minus the probability of not something. Okay, well, the probability of at least one thing is equal to 1 minus the probability of what's the opposite of having at least one of them? Well, that would be not having anything at all. So really, these are the same formula, but I kind of like to write this formula down because it just helps me a little bit with these at least one problems. All right, you flip a coin 3 times, find the probability that at least one of your tosses is tails. So we've got the probability of at least one tails is going to be equal to 1 minus the probability of no tails. That makes total sense, right? We're basically saying that those 2 things are equal, and they are. All right, so what is the probability of no tails? That's what we really care about. Well, we have to think about what that probability is. So, if you look here, how many different situations do we have when we're flipping a coin 3 times? We've got doot, doot, doot. Okay, we've got 2 options on the first flip, we've got 2 options on the second flip, and 2 options on the third. So we have 8 different outcomes. In fact, we've got the heads, 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 that's one outcome. We've got the heads, heads, tails. We've got the heads, tails, head, etc. Now, which one of these is no tails? Well, no tails would be only one situation. It would be the heads, heads, heads. So this is going to be equal to 1 minus the only situation where there's no tails is the heads, heads, heads. So that's one situation out of the 8. Okay, now we need to make sure we reduce that fraction here, or combine like terms. We got 8 over 8 minus 1 over 8, and it gives us an answer of 7/8. Now, could we have done this the other way? You certainly could have, right? We want to find the probability of at least one tosses his tails, and you can see that every single one of these outcomes has at least one tails in it, except for this outcome. And we know there's 8 outcomes, so these are the 7 that work out of the 8, right? And I didn't want to circle all of them, but that's one, that's the other one, etc. All right, let's check this one out. Ms. Sorensen has a box of cookies. She's a big fan of cookies. And 12 of them are chocolate chip and 8 of them are peanut butter. If you pick out 2 cookies at the same time, what's the probability you get at least one chocolate chip? Okay, well, that's going to be probability of at least one chocolate chip is going to be equal to 1 minus the probability of no chocolate chips. All right, well, what's the probability of no chocolate chip? Well, first, to do that, we really have to think about what does it mean to have no chocolate chips? Well, that actually means 1 minus the probability of getting all peanut butter. So that would be, remember, we're picking 2 cookies, so that would be a peanut butter, comma, peanut butter. That's the only situation where you would not have a chocolate chip. All right, so let's calculate what the probability of peanut butter and then peanut butter is. That's going to be, getting a peanut butter is 8 out of 20 cookies total. And remember, we're picking a peanut butter, so we've got 1 less peanut butter and 1 less cookie. All right, what does that become? This becomes 1 minus, obviously 8 times 7 is 56, 20 times 19 is 380. And now I need to convert my 1 into a fraction, and I'm just going to erase that here and write that as 380 over 380. Now, 380 minus 56 gives me 324, and then 380 in the denominator. Now I can reduce that fraction using our method that I've taught you, and that's 81 over 95 is our answer. Okay, here's another one. This is a little bit different. Let's check out the wording here. It's saying that Ms. Sorensen has a box of cookies. 12 of them are chocolate chip. 8 of them are peanut butter. If you pick out 2 cookies, what's the probability you get at least 1 peanut butter cookie? So again, we're still picking out 2 cookies, but now we're trying to get at least 1 peanut butter. So the probability of at least 1 peanut butter is going to be equal to 1 minus the probability of not getting a peanut butter. Well, what's the only situation where you don't have a peanut butter? That would be if you picked a chocolate chip and then a chocolate chip. Okay, so we have to calculate that. That's going to be equal to 1 minus, okay, let's calculate this probability. That's going to be 12 out of 20. Then remember, we got to pick another chocolate chip, so now we're down to 11 out of 19 cookies. Okay, what does that reduce to? That reduces to 1 minus, multiply across the numerators. That gives me a 132 over 380. Alrighty, and then I can go ahead and subtract this one here and write it as 380 over 380. Subtract my numerators and I get 248. My denominator stays the same at 380. Reduce that fraction, I'm left with 62 over 95. That's my final answer. All right. Looks like that's the same problem, so I'm going to skip that. Here we go. Now these problems are a little bit different, so we've got to make sure we are, oh, was the last one different? Oh, look, it was 4. So we do have to do this one. I'm sorry. Silly Miss Sorensen. All right, here we go. Miss Sorensen has a box of cookies. 12 of them are chocolate chip, 8 of them are peanut butter. If you pick out 4 cookies at the same time, what's the probability you get at least 1 peanut butter? Well, probability of that is going to be 1 minus the probability of not getting a peanut butter. So that would be chocolate chip, comma, chocolate chip, comma, chocolate chip, comma, chocolate chip. So that's going to be equal to 1 minus 12 out of 20. Then we pick a chocolate chips. We're down to 11 chocolate chips out of 19. Down to 10 chocolate chips out of 18 cookies. Down to 9 chocolate chip cookies out of 17. Multiplying across, I get 1 minus 1880. Multiplying across the denominator, I get 116280. Okay, now of course I can rewrite this 1 as 116280 over 116280. Subtracting those fractions, my numerator becomes 290 and my denominator becomes 323, and that's not reducible. Okay, now these problems are different because they give us a percent. And certainly it's a little bit harder, but not tremendously. So given any year, the probability that Manson gets hit by a major forest fire is 6%. Find the probability that Manson experiences at least 1 major forest fire in the next 3 years. Well, we have to write down that the probability of a forest fire is 0.06, right? That's the probability of a forest fire. So the probability of no forest fire is going to be its complement, or is going to be 94%, or 0.94. So this question is saying find the probability that Manson experiences at least 1 major forest fire. So the probability of Manson experiencing at least 1 forest fire is going to be equal to 1 minus the probability of no forest fire all 3 years. So that would be no forest fires, no forest fires, no forest fires. Okay. Now, to calculate this probability right here, that's going to be 1 minus, well, what's the probability of no forest fires the first year? Well, that's going to be 94%, or 0.94. What about the second year? Oh, that's also 0.94. What about the third year? Oh, that's also 0.94. So we can rewrite this as 1 minus 0.94 to the third power, which gives us 0.1694, which I can reduce to 16.9%. Or you could say, if you want, 169 over 100. Which one of these answers will I accept? I will accept all 3, although I probably prefer the percentage because we're given a percentage in the problem. All right, that's it for now, folks. I hope you have a great day and learned a little bit.